So to start with, first of all, let me introduce myself to everyone. I'm Shivranjan. I'm currently working with SETU as head of AI engineering and been here for almost 2.5 years now. My overall experience is into building products for citizen scale, consumer electronics, and which have mix of AI as well as edge compute. Happy to bring in all that experience to the discussions that we are going to have in this cohort. Now, before we jump any further, I have couple of questions to everyone in the room. One, definitely would love to, will come to the interactions. Through interactions, I'll come to know you because we are already 25 members. I don't want to spend time on introducing each one. But would like to understand how many of you are from the system architect kind of a background. If you could just raise hands or drop a yes in the chat, it will be really helpful. Okay, Bhavesh. Okay, one person, system architect. Okay, fantastic. Uh, okay, and how many of you are from, let's say, a uh, development, right from a hands-on coding? You are doing the hands-on coding right now, something like that, which has the combination of both AI plus traditional software engineering. Would love to know that. Okay, so okay, fantastic. Uh, uh, is anyone here from product management or product engineering or solution engineering background? So not doing hands-on, but you have fantastic. Okay. So, Arup, and if I'm missing on some of the streams, if you could tell me uh, what is a major contribution that you but app engineering. Okay, fair enough, Pankaj. So we spoke to tech consulting, fantastic. So we have tech consulting. Anything else? Governance, risk, compliance. I was just coming to that. Okay, we have cloud architects. We have cybersecurity background also. So I think operations, interesting. Uh, Telecom and wireless communication with customer engineering, fair enough. Okay, Mayank is into system. Okay, fantastic. GRC. Okay, AI implementation, but not hands-on. Fantastic. Which is very good. Uh, uh, so we have good mix of people here in the room. So we'll take benefit of that because when we start looking at uh, agentic AI and therefore the Claude AI architect certification, we need to understand the wholesome picture of the entire system. So we'll take benefit of that. I have one more question before we delve into the content. How many of us are from US, Canada, or uh, some other place from a geolocation standpoint? Iran, USA. Anyone from Australia? Okay. Arup is from Netherlands. Fantastic. Uh, okay. Irving, Texas. Okay. Anyone from Australia or how many of us from India? A quick. Okay. Harnish, Ribbon. Okay. Okay. Okay, so we'll keep in mind on the time also, because it's either too early or a late night for some of you. So we'll try to keep the. Yeah, thank you. Okay, fantastic. So before we uh, go into the today's session, I have two major aspects. One uh, is uh, one is your roadmap, your learning roadmap for the for this duration of the entire cohort, and number two, you having access to Claude. How do I say, the Claude Pro, at least Claude Pro account, uh, which you can use for our sessions. We will talk about both, but first, roadmap. Uh, if you can give me yes or no in the chat, or give a raise of hands, or show of hands somehow. Uh, all of you have access to the roadmap link. Uh, you must have received it via email from Angela. Yes, yes, fantastic. And you were able to log in. Uh, Okay, okay. So if you have not logged in yet, you can enter the email that you have used for your registration. And once you enter your email, but please, yes, um, you have raised hand, Mumtaz.
No, so everyone has it.
Acha, okay, everyone has it. So fantastic. So if you click on get OTP, you will be sent an OTP, and
So when I logged into it, directly put me into my roadmap. So
hmm.
I can come back to this later with some password, I would assume, or my OTP, right?
It's OTP. Every time you
Okay.
try to log in, uh, you will be asked to enter your email and you will receive the OTP. There is no password.
Okay.
So this is our proprietary LMS of SETU, the learning management system, which we will be using to uh, follow the pathway, as well as ensure that all your contents, links, documents, code that we are going to use in our sessions is available here. Uh, and Pinjala will specify the timelines every day when the recordings and content will be available. But generally, you can see that uh, day wise the segregation has been provided. So let's say we are at day one. So you will have any open content that is there. Let's say a blog link or a research papers link that we would like you to go through, walk through, will be made available under open access. And the content, the recording, and the code that we're going to use throughout our session, we will be making it available under premium access, right? So you take any of the topic, any of the day, you will have the description of that day, some open access content, and there will be a premium access content. Don't worry, currently it is empty because we have not shared anything with you. Today is our first session, and in the first session we will be discussing all these details. So I'll wait here for exactly 30 seconds. If anyone is facing issues in accessing this roadmap, please raise the concern so that uh, we may try and address it early in the session itself. Okay, assuming no one has the difficulty in accessing the roadmap, I'm going to go ahead now. So this is okay, what should we see in the premium access. So in the premium access, you should see the code that we will be using in our session, the recordings, and um, uh, the specific things that we are going to use in our session. Anything which is open source blog or a YouTube video we would like you to go through, or a research paper which is yes, recording is equal to this 2.5 hour session. Hope that is okay. Yeah, great. Thank you. Now, the second point, one was the roadmap. Everybody has access to the roadmap. Second is uh, the uh, subscription to the Claude, the Claude Pro subscription at list. So if you have Claude subscription, then you can see it here. Either you will have a Claude Pro or Claude Max. Claude Pro is minimum that is required so that we can make use of Claude Code uh, and Claude Cowork capabilities. So that is my next question. Is there any doubts on this? How many of you have the Claude Pro subscription?
So actually, the thing is, right, my personal laptop is out of order. I may have to fix it. So I'm using my official laptop. Over
Mhm.
there, I think I do have Claude Pro, but the problem is I'm not able to join the Zoom from there because Gmail access is, Gmail login is not allowed.
Okay, okay.
So I'm on my mobile for this. For this. Hopefully by weekend I'll sort it out.
Okay, that is okay. So I will, okay, let me address that. Yes, so if you have the desktop or a laptop, working laptop by next weekend also, that is fair, no issues. Uh, but make sure that you have access to that. Arup has asked, okay, so I will need to make Claude Pro account. Yes, at least Claude Pro account is required. That's the bare minimum that you will have to subscribe to.
Will it be required today onwards, or is it fine to take it maybe tomorrow?
Maybe tomorrow onwards is also okay, because today we are going to walk through the setup. Setup as
Got
in, I'm going to show you on my screen. Starting tomorrow, you will see things on your systems happening. So would prefer if you have this at least from tomorrow. Um, but definitely we need it from when we start the coding with Cloud Code.
Got it. Thanks.
Yeah. I'm going to pause here for 30 seconds. Any questions, any doubts that you have, would like to address first, and only then go ahead.
So one
Uh,
question, Shivaranjan,
Yes.
that given that we will be writing Claude code,
Hmm.
uh, to what extent we will be going into Claude code?
Uh, Sorry, could you
My
please?
question was
Huh,
to what extent or depth we will be going into Claude code, and I'll clarify on why I am asking that question,
mhm.
because uh, some of it may start to define what kind of hardware I am using to write some of this. You know, because if you get into CUDA programming and things like that, then there might be need for a different hardware. But I'm just assuming, and therefore clarifying also that that kind of setup might not be required for the purpose of this class. Correct?
Yes, absolutely
Okay.
correct. We are not going into GPU in a build
Okay.
programming.
Okay.
Uh, what we will be using Claude Code or the Claude uh, desktop app is for two things. One, we will ensure that we are using Claude Code, and therefore we are building some of the artifacts. Sorry, here the skills. We are able to create some skills. We are able to use some of the existing skills which are given by Anthropic. Build some of the routines that as in you can see here, it's a local routine that only runs while my computer is awake and online, and I am actually building a small routine for me. So something like this routine you can build sub agents which will help you generate code much faster. Then you have some of the schedules that you can build, and we use dispatch also, so that from Claude Cowork to Claude Code, how do we do the handoff? All those things are required. We will use therefore the Cowork setup to work within our desktop. So we allow Claude Code, Claude desktop app to work within our desktop,
Got it.
create files, remove files, update, edit, Excel, Word, and other things, and also use some of the skills. So let's say there is a skill called brainstorm. We will allow it to use the brainstorm skill. So for all that, we need the Claude Pro.
Sure.
Basic laptop is good enough. By basic, I mean 8 GB RAM or whichever is the standard configuration.
Got
You
it.
can
Got it.
use
Sure, Shivranjan.
CPU.
Okay. So, Shivranjan, one more thing, and this is just a pure play request to just broaden the way we think and execute things. That when we go into a specific technical implementation of use cases, specifically, only request would be if you can extrapolate uh, between Claude and everything else, because today people don't only use Claude. Depending upon the situation, comfort, what people have been doing, people can use a lot of other tools also. So just extrapolate on what it would mean to work within the Claude environment and non-Claude environment. When I say non-Claude, meaning an equivalent environment, whether it is agentic or coding. I'm not saying that show something, but just make some commentary so that we are able to correlate that things will work probably a similar way or very differently, or by and large the same. When you are working with anything that is non-cloud, so that would be helpful.
Okay. Okay. Fair enough.
Okay.
I'll try and do this, but given our focus is on Claude, my primary interface will
Sure,
be
sure.
Claude. Hope that is there. So let me now take it to the session. Now, here is what we are going to do today. We are going to walk through all the five tabs that are here. Assessment, we will discuss about what is what is a Claude Code Claude Certified Architect exam consists of, different domains, the scenarios that are there, how the distribution is among these domains, and therefore what it means for us. Then we'll walk through the entire curriculum as a phase, starting from foundation to multi-agent system. So uh, when I'll just shorten it. So foundation will have, let's say, 3 sessions, then basic agents will have two. We'll spend good 6 hours, 7.5 hours on productionizing and hardening the agents, or eval engineering will have approximately 5 hours of time and effort. Governance and cost is a separate. Advanced multi-agent system is beyond vectors retrieval and some other things. So we'll walk through uh, here, and then I'll answer some of the questions that you might have at the back of your mind. Then we'll walk through what is an agent. So once we know what is a Claude Certified Architect exam structure is, we will try and see how does it maps to our 52 hours of effort. And through that, once that is complete, we'll move to what is an agent. We'll try and understand what does an agent means, and how it is different from a simple plain large language model based system. Now, because we are going to speak of agent in detail, we will correlate it with the LLM. We will go through we will try and touch base on the three problems it tries to solve and how does it work, uh, because this basic uh, consideration is required if you are a product manager, if you are a solutions architect, if you are a risk and compliance professional, if you are a cloud professional, or if you are a hardcore developer. In all the five situations, we need to understand what is an LLM from the architecture point of view. And I'm not going to go into depth of the architecture, but touch base on two or three important things that make sense for all of us who are going to either write the code or decide the cost, the risk procedures, or risk controls basis that. Uh, so we'll take on that. Then we'll try and decode the taxonomy of LLM applications, and then finally we'll go to the four different patterns that you generally observe in any agentic applications per se. So if you are talking about an agent, then you will have one of the four agentic patterns arriving there. Now, these are the foundational patterns. Different literatures will refer to them in different ways. Different frameworks will try and implement these in different ways. These are the four foundational patterns that you can come across. And then at the end, I'll take all of your questions. Meanwhile, I have one question here. Is it necessary to have desktop version of Claude, or we can use web-based Claude? Bhavesh, desktop version is preferred, partly because you will have your code also getting generated. We will have the session is planned in such a way that some of the sessions are you just execute the code and we walk through it. But then there are sessions where you have a broken piece of feature in the code embedded. You need to course correct it using Cloud Code, or another day you have a uh, synthetic dataset generation. So if you have it in the desktop version or the laptop desktop, whichever version you are using, that will be really better. If you start using it via here, there is no harm in it, but the only challenge will be you will have to copy paste all your files, folders, download them, and that will take a lot of time, very honestly. So uh, this is
Shiv,
okay,
I
but
think you will have to zoom your screen
okay.
so that everyone can see it better.
Okay, thank you. So you can work in a Cloud Cowork if it is a pro account, but the problem is in the web version you do not have a code setup. So for code you will have to have your uh, desktop app only, or a CLI at least. So you have two
Good.
options: CLI or desktop app. Both are okay, but we need that. Web version will not be sufficient enough.
Okay. Okay.
Okay, so now I think this is visible. Okay, fantastic. Okay, any questions, any doubts, or we can jump into the discussion? Jenny, you were saying something. Okay, great. So,
Just a quick question. So, for what is the estimated amount of money that we have to spend on the Claude subscription for this course?
I'm not sure,
Yeah, I'll
but
tell you for pro it comes to around $2,000, 2,000 rupees a month.
hmm,
That
yeah.
should be it.
Srividya, does it answers your
Yeah,
question?
yeah, it does answer. See, at work laptop, I do have it, so I don't know the amount. So, if my personal, I'll have to pay, right?
Yeah, yeah, yeah. Fair enough.
And that's the number.
Yeah. So, so when you do it monthly, it's roughly $20. But I think now with India specific pricing, it's 2000 rupees. I'm
Yeah,
not sure
correct.
whether it is inclusive of GST or not, but 2000 is the number that I know. Okay, so again, these links that I'm showing you on the screen will be made available to you inside your learning management system or the roadmap that I just showed you at the beginning of this session. But for the clarity, I'm going through each of them right now. Hey, thank you, Aru. I could see your message just now. Okay, so a Claude Certified Architect Foundations, and there are four other, uh, each entangled within each other. So Claude Certified Associate, Claude Certified Developer, Claude Certified Architect, Foundations, and Claude Certified Architect Professional. So these are the four different certifications that you can have. Uh, so I'll just have a walkthrough of Claude Certified Architect Foundations.
So ours is a foundation or ours is a professional?
No, wait one second.
I think ours is a professional if I'm not
Professional,
wrong.
yes, it's a
Yeah,
professional one.
correct.
No, you will actually start with foundation because even foundation level is pretty tough, and then move to the professional.
Okay,
So
so the
Claude Certified
scope of our one minute. So Jenny, scope of our training is to be eventually when the classes are done, we are aiming for foundation certificate or professional certificate. I thought it was professional.
You will first start with foundation certification instead of directly jumping to the professional certification. What we will train you in in the session will help you for both developer certification as well as architect foundation certification as well as architect professional certification. However, the distribution of the weightages are different for each cases, which you can go through, and we will share the exact links, official links from where you should see it. Preparation will help both, but still our suggestion will be when you go for certification exam, start with foundation and don't jump to the professional at the start. It will help you. Shiv, go on, please.
Yes. Thank you, Jenny. So here, and there is a specific reason why we start with here at Architect Foundations, because at core it goes to the these five specific domains: agentic architecture and orchestration, tool design and MCP integration, cloud code configuration and workflows, prompt engineering and structured output, and context management and reliability. These are the five domains you will find in any of the AI applications that we see today in the solutioning space. If you go to professional setup, then you have solution design and architecture, cloud models, prompting and context engineering, integration, evaluation and testing, governance, stakeholder communication, and developer productivity. So when we go towards, let me go to this part. When we go towards eval, productionizing, governance, and cost, these things will help you prepare for these aspects of your the architect professional certification. But we start with these five at the core, because these five, when they are spawned out, you will come to these seven topics ultimately. So before you come to solution design, architecture, and integration, ideally you should know how does the orchestration happens in an single agent, multi-agent system. What are different patterns in multi-agent system? Therefore, for multi-agent system, how do we design tools and how do we integrate MCPs, which will help you in turn help for integration and governance and safety and risk management, building controls around GRC. So all of that. So hope that answers the question. Now coming back to most of the discussions that will happen are around, wait, where is it? I'll keep it here. So any reference, this will become our like the website that you can go to. It's Anthropic partnerskilljar.com, Claude Certified Architect Foundation Certification. You will see different things that they have provided. And the exam guide is also provided over here, which I was showing you at this point. Now, if you see here, it says very clearly that there are 5 different domains with their weightage. Each of these domain is covered in depth when we go to our curriculum. So let's spend some time on our Claude Certified Architect setup. In the assessment, generally the questions asked will be from 5 different domains. Those 5 domains are agentic architecture and orchestration, tool design and MCP integration, Claude code configuration and workflows, prompt engineering and structured output, and context management and reliability. Now, don't worry, you might not have heard about structured output, which is okay. We will deep dive into it. We will build the structured output setup for Claude specifically. You might have heard about context a lot. But how do we manage that context is also we will go in depth. So in an assessment, there will be 5 domains, and among these 5 domains, there are approximately 6 different scenarios. Customer support resolution agent. So you know how to build a customer support resolution agent, both as a solutions architect or as a developer. Using Claude Agent SDK, it handles high ambiguity requests. There are 3 different tools that you can see, 3-4 tools. And therefore, how do you actually make sure that given a scenario of customer support resolution agent, what are the different agentic architecture and orchestration decisions and integration aspects you need to consider? How do you design a tool? How do you build MCP, a custom MCP for your own applications, or use existing MCPs in your application? And to give you very specific responses to the customer, how do you manage the context? And therefore answer the question, is my agent reliable? Now, whether it is customer support agent or one of the use case that we are going to look at, let's say we are building AI agent for a auditing firm, and in auditing, your disputes will never arrive on the day when you are having the conversations. The dispute will arrive 6 months down the line when the regulatory body raises some questions, and at that time you need to be able to answer that what agent did on that specific day when the conversation was performed, and therefore what are the 2-3 things that happened, which tools were called, what was the context fetched from which rule book. Each and every step will have to be presented when your client asks you, okay, a regulatory body has come back with this question, which is a dispute now. Help me understand what are the things that agent did on this day 6 months ago to arrive at a particular answer. Now, from that angle, we'll start looking at all the aspects of, let's say, customer support resolution agent or code generation with Claude Code. So you're going to use Claude Code to generate the code. You might not write a code by yourself, by hand, entire code end to end, but then we cannot be asking Claude to generate code on an HTML page. You need to be very, very specific about specifications, architecture that you're going to follow, services that you're going to use. Uh, some of you might be using Azure as a platform. Some of you might be using AWS as a platform, or some of you might be on a very other specific custom platforms. So you need to be very specific in terms of code generation, debugging, and documentation. How to use different skills that are provided by Claude. How do you generate new skills which are very specific to your use cases or your workflows? And how do you use Claude.md configuration files at 3 different levels? There is a global, there is a repository, and there is a project or a folder specific Claude.md configurations. How do you perform those is what you will see in the scenario 2. Scenario 3 is a multi-agent research system, again with Claude Agent SDK. How do you build a multi-agent system where a coordinator agent delegates to a specialized sub-agents? So not, let's say you are asking an agent to perform a task of uh, adherence to service level agreement, therefore analyze the tickets, the issues raised by the clients, their severity level, assign an appropriate resource within your team, log a ticket on Jira or whichever board you are using, track it throughout during the SLA, after the SLA, perform root cause analysis. Here, you will not ask a single agent or a single LLM call to perform all of these things, but in fact, you will allow a coordinator agent to delegate these tasks to sub-agents. One of the sub-agent could be root cause analysis. One of the sub-agent could be understanding SLA of severity level. Another sub-agent could be identifying the severity of the issue raised by client, something like that. So each scenario unfolds some of the primary domains. So scenario 2 has Claude Code configuration and workflows and context management, while 3 has agentic architecture, tool design, and context management. Now scenario 4 is developer productivity with Claude. You build developer productivity tools with Claude Agents SDK. So two things. One, understand legacy system, generate a boilerplate code, and automate repetitive tasks. You can also, here you will use built-in tools of read, write, bash, grep, and glob. Also integrate with MCP server. Cloud Code continuous integration. So you will use Cloud Code for your CI/CD pipeline. We will build GitHub actions, automated code reviews, generate the test cases, give feedback on pull request. You design prompt that give actionable feedback and keep false positive low. So prompt engineering is what we will discover over here to perform continuous integration and continuous deployment in our system. So we'll build a pipeline where right from the client discussions, everything will be handled by Claude Code. You give a transcript or you point a Claude Code to the client discussions. One of your sub-agent spawns, identifies the requirements, builds the feature, gives it to your coder sub-agent. Coder sub-agent first creates the test cases and therefore generates the code, implements CI/CD pipeline, identifies the gaps, errors, comes back with the resolutions to those errors, and then implements them and gives you a final code that can be pushed to the production, something like that. The scenario 6 is structured data extraction. You build structured data extraction system with Claude. So most of the times when you are working with documents, let's say GST invoices or payslips or any other kind of an invoice, you will have data which is much more structured. Let's say you want it to extract some of the fields from those invoices or those documents. You have a contract, you have a master service agreement, or you have a service level agreement. specifics. You want to extract the client name and the end date of the agreement and the total payable amount under that agreement, all those things. So you allow Claude API to walk through your document and extract that specific information. We additionally also look at how I can implement the guardrails protecting the personally identifiable information. That means how do I perform data anonymization step before I send any document or any information to the LLM. And that's how we try and observe the scenario 6 too. So in the assessment, you will have questions across 5 domains, but out of 6, any of the 4 scenarios can be chosen. That's the Anthropic's part, that questions will be asked on 5 domains, but out of 6 scenarios, 4 will be chosen. You may not come across other 2 scenarios that are already presented in your assessment. Generally, if you see here, number of questions are 60. You get 120 minutes, and you need to score at least 720 in order to get the certification. That's the Claude Certified Architect baseline curriculum, you can say. The same is the case here. In Claude Certified Architect Professional, you will be asked 63 questions for 120 minutes. Again, passing score is 720. That's the whole setup. Now, before I jump into the session and curriculum, yes, any questions that you have? I can see 2 questions. 720 is a weighted score. Yes, 720 is a weighted score. It is clearly mentioned here that 720 is a weighted score. I think it was mentioned on Architect Foundations page. Scaled 100 to 1000, whatever score you get from the MCQs. I have another question from Sri Vidya. In the new type of org structures with FTE and FSC role, where will solutions architect role fit? Sri Vidya, can I take this question towards the end? Hope you don't mind.
Yes, I just put it. No worries.
Yes.
Just
Thank
wanted
you.
to hear perspectives because things are changing.
Yes, sure. Thank you. Okay, any questions on Claude Certified Architect exams base curriculum or the baseline curriculum?
No, by and large, okay.
Okay, sure. So now we go to our 21 days of the curriculum. So today we are observing the, okay, I'll just have to here. So we have 21 days spanned over here. You have, and what I've tried to do is I've tried to convert them into phases. So there is a foundation phase. It has 3 sessions. If we discuss introduction to agentic AI, understand what is an agent. Tomorrow we will go through constitutional AI and the Anthropic safety framework, one of the frameworks that Anthropic has released for the safe, responsible usage of Claude. How does that gets fitted into our entire effort is what we discover, where we try and build a agent system where we try and draw different clauses, different aspects from this safety framework, and we can then correlate it to anything else. Day 3, next Saturday, we will try and install Claude Code, Cowork, use Cowork, dispatch the task to the Claude Code from Claude Cowork as a agent. So these 3 days will set us up for two things primarily. Point number one, how do I use Claude app? Uh, and when I say Claude app, both chat, Cowork, and code, as well as how do I ensure that I'm able to use those slash commands in the Claude CLI or Claude desktop app. That's the goal at the end of the day 3. The second phase is the foundations and basic agents. So your day 4 will look like your first agent. So you will take an LLM application setup. You will try and convert it into an agent, and from that agent you will not take raw output, but you will try and convert it into a structured output data that you can utilize for upstream or downstream applications. Let's say you have a ERP system that needs a data in a specific format, let's say JSON or some other type of a format that you want to use. You convert the output of the LLM in that structured type, and you use it your downstream applications. The day 5 is the foundational RAG setup. So your knowledgeable agent, this is where you start looking at your context. How do you build a working RAG pipeline? How do you build that most simple RAG pipeline, all ingestion, retrieval, generation, everything? Don't worry about the words if you are unfamiliar with them. We will go there, we will try and understand how each of these steps happen. How do we ensure that the private knowledge base that we have within our organization or within our projects, how do we allow LLMs to process that? That is the question that we will try and answer. So how do you give an agent knowledge beyond its training cutoff is one of the bigger questions that we are trying to answer here. The end outcome of day 5 will be a working RAG pipeline with a chosen store and a chunking strategy. A document ingestion, embedding, and semantic retrieval on a sample corpus. We compare stores and chunking approaches on real documents. We will not take plain markdown or txt file for chunking. We'll take a PDF with multi-columns, images, tables, so that you understand in reality how do you handle these documents. Therefore, we build a retriever, and we will call it done when the agent answers domain questions from retrieved chunks, not from parametric memory alone. That means not from the training, but from the knowledge base that you have provided, your agent is able to respond to the questions. The third phase is going to be building advanced agents, where we'll spend most of our time. There are 5 different aspects to this advanced agents setup. We will start with understanding and implementing advanced context engineering systems. Therefore, understand what it means for me as a system architect or a solutions architect. Also, try and understand it as a product sense, that why making every token count within the LLM and within the agentic setup is important, because every token costs you something. Then we will go to building tools, the action-oriented agent, where we will use function calling and tool design, and we will try and build a first of the React agent. The day 8 is about agent that remembers. That means we are going to add the memory to the agent. Now, generally in the memory, we will talk about multiple things, but how we have structured the day 8 agent that remembers is about 5-tier agentic memory, which is infused vertically. That means whether it is a single agent or a multi-agent, the memory is available to all the agents, which will help us understand and decode 2 things. One, which type of a memory is required for which type of a problem statement. That is one. And second, how obvious it is for us to not think about it, but also take care of the context leakage. Let's say you are working in a vendor management system and your bot is supposed to answer from vendor A's contract. And if you're building advanced RAG architecture such as a graph RAG, where you are not putting chunks, but you are looking at graph and nodes and edges, the higher chances is that MSA of one vendor is going to clash with MSA of another vendor, vendor A, vendor B. And when you ask a question about vendor A, the context leakage might happen and you will get some reference of vendor B. Now, why this is important? Because if you go to governance and cost, one of the control or one of the major issue in the risk and compliance that will happen is even in the retrieved context, if the leakage has happened and a cross reference has happened, then your agent is not compliant with some of the regulatory resolutions or regulatory circulars that you have. So you need to be very, very sure about it. Then on day 9, we will see from day 7 and day 8, we have memory and tools. On day 8, we'll combine multiple tools in a single agent setup. And day 10 is where we actually see agent working as an agent. So we will have self-correcting agents. Till day 9, you might see that agent is failing. And the bigger question is, how do I ensure that a failed agent recovers? So a self-correction point will be added on day 10. That will ensure that a resilient agent with a reflection, circuit breaker, fallback, and human escalation will be implemented. Now, by day 10, you will have, apart from agentic sense, you will have two other major artifacts to ponder over. Artifact number 1 is LLM gateway. That means you can integrate as many service providers or as many model providers without modifying your other code where you are integrating your prompts and other things. And the second part is your circuit breakers and fallbacks. How do you implement that as a architecture, not the aftermath of the uncontrolled blast radius, right? So as a software engineering, if you start looking at that part, then your efforts are always controlling the blast radius. How can I ensure that I catch the errors, issues, or false answers way before it reaches the end user? So you try and do that by day 10. You will have that as an additional component. The phase 4 is productionizing and hardening agents. You will have a secure agent. That means you will implement guardrails, PII, and compliance aspects in your agent. Day 12 is about persistence. We will focus here more on the long-term memory by looking at the 5-tier agentic memory that we were seeing in the agent that remembers. And then day 13 is more about deployment and observability. How do you ship that? You take Docker, you take and other things that you have. How do you containerize your service? How do you ensure that your application is ready for next stage of evaluation? Because no application, no agent is ready to be deployed unless you have an evaluation setup ready. So therefore, on day 14 and 15, we deep dive into RAG evaluation, where we will come across RAGAs as a framework. We will come across red teaming, adversarial evaluation, and building golden data set. Now, if you are a forward deployed engineer, if you are a forward deployed solutions engineer, if you are a solutions architect, if you are a product manager, part of your day-to-day responsibility will be building the golden data set and building red teaming evaluation suite for your application, which will give you go no go of agent deployment in the production setup. We also have total cost of ownership, GRC to spend on. So given a golden data set and the eval harness, how do you judge the agent? What are the things that are required for an agent to work, right? Uh, you estimate the cost way before your agent is in the deployment phase. You try and draft a system where stakeholder ready total cost of ownership model is available. You start looking at NIST, you start looking at EUAI Act, you start looking at ICMR, you start looking at DPDP Act, you start looking at those clauses, you start looking at those aspects which are never discussed when the agent goes into the deployment. And session 14, 15, and 16 are the gaps why POCs fail in deployments, very honestly. Now, having said that, once we cover the governance and cost aspect of it, we will go to multi-agent systems. For the first time, we will go beyond vectors in terms of retrieval of the context. We will go to graph, we will go to agentic retrieval. Then we will observe the hybrid architectures of agents, manager worker patterns, and few other patterns. Somewhere here, we will see the different framework, which is a Lang graph and Lang chain. Day 19 is more about multi-agent collaborative systems. So learnings from day 17 and 18 and all the learnings synthesized from day 1 to day 16 will go into day 19 and day 20, where multi-agent collaborative system is will be built. So ultimately what we will build is a multi-agent workflow with communication and observability across the boundaries. And in the co-creation stage, the ask is, can you integrate architecture, build, evaluation, and documentation into one single system? So let's say you take this secure agent setup and then convert it into a complete end-to-end architecture that you can follow. So what does that mean? How do you build architectural decision record covering safety, compliance, and cost? How do you write those prompts? How do you write those workflows which will generate the code for you and move ahead with being ready for compliance audit? So you have ADR ready deliverables using design, evaluation, safety, and cost, including the prompts that you have written, including the change log, including the CI/CD logs that you have. The capstone is, we will discuss this, but more than that, the capstone is about you starting to modify from here. So once you know how does Claude Code works, Cohort works, and how is the agentic toolkit of Claude Code, you start taking capstone with you, and you start modifying as the day progresses. So let's say we are building first agent, raw output to structured data. Then you probably take the capstone and add a structured data component to your automated document scrutinizer. Again, the problem statement will be released to you sometime next week, if I'm not wrong. Anuchani or Pinjala can correct me. But we'll release the problem statement next week, and you will have access to the problem statement right from week 2, so that by the time we come to hybrid architecture, you have your entire one agent application ready, which you can use as a reference architecture at your workplace. You can use it as your preparation material for your Claude Certified Architect exams. So that's the overall 21-day plan. Every day is 2.5 hours. Any questions, any thoughts? And before you ask any question, I have a simple submission. So the distribution we will try and keep is 40-60. So we'll discuss the architecture 60% of the time. and 40% of the time I will walk you through the code, or you will be generating the code using Claude Code. That is something that will try and follow, because I also understand that some of you are uh, not into hands-on coding every single day nowadays, even though some of you would have done that previously. But we will try and focus the our discussions around architecture, design decisions, the questions I should ask Claude or these LLM agents to generate some of the artifacts for me, and how does that work. So some of the top questions that you might have on your mind is, what if my code does not match the shared solution? In the agent, in the LLM space, the probability drives everything. That means if you have run the LLM once, that's the only unique run that will have its lifetime. There is no second unique run of the same repetition that you can generate, unless you're doing a lot of hardware stuff, something like that. Now, that is completely fine because our architecture is the main artifact. If our system follows architecture, we'd not worry about code, because whether my code is doing the same thing that I'm expecting will be defined by safety, observability, and correctness framework. So do not worry about whether you are, generating the right code or wrong code. That will be decided by these 4 or 5 things that we are already going to discuss. Is this Claude specific or portable to other LLMs? Currently, it is Claude specific. PPDM, memory tiers, tool schemas, evaluation, and traces transfer across vendors. SDK syntax will change, control principles do not. So there is Claude Agents SDK. This is how your Claude Agents SDK is. Then you have Google Agents SDK, Google SDK, and then you have OpenAI Agents SDK. So by and large, you will have the same argument that how the agent loop works, Claude Code features, work with sessions, persist sessions to external storage, streaming input, handle approval, stream responses. Agent development kit that Google offers will have, where is my, I can go to build agent. So multi-tool agent, agent team, code with AI, agent config, graph routes, data handling, human input. More or less you will have the same setup. Now, answering to the another important question, portable to other LLMs. From the LLM point of view, our architecture is portable, because as I told you, we will, by day 10, when you are completing your self-correcting agent, you will have an artifact called LLM gateway and fallback. Those two will help you ensure that your entire architecture is portable across LLMs. So is everything to be solved by agents? Probably not. You will see this. When to use agents, when not to use agents, how does it depends on deterministic output, feedback, workflow, all those things. So we'll try and understand when to use agents and when not to use agents. What must be logged from day one? So this is more about your observability. So we start logging everything from day one. You will probably see the goal, plan, prompt, tool schema, tool input, tool output, retrieved sources, rejected evidences. Everything is logged from day one. We do not treat logging the information on day 2, day 3, day 4, right? Do you need to memorize every tool or API signature? Probably for non-developers or non-tech people. No, not at all. The skill is the architectural judgment. You should know when to use a tool. Let's say you want to work with a Excel in a Claude Cohort. So you should know that there will be a skill to work with the Excel. You can search that and you can start working with it, or you can write a prompt such that Claude agent chooses Excel tool to work with the Excel files based on your prompt. So prompt writing a prompt becomes a skill, not the tool name or the API signature. Now, most of the times we will have architectural time discussion leads. That means you will ask the questions. We will try and defend the choices through your questions, through your observations, predict the risks, name the missing controls, and decide what changes when some design changes across. So that's the setup. Now, you might say that I work at X and they use Y LLM. Keep the architecture, replace the adapter. That's the only thing that you can, I can think of. Now, how will certification assess day one? Probably we will try and discover this, that from day one itself we will start looking at these 5 domains and only then move ahead. Now these are some of the questions I thought you might be asking. So I'm going to wait here for a minute before I jump to our discussion today on agents, LLMs, and taxonomy and other things. Any questions that you have basis the curriculum? Uh,
Hi, Shivrajan.
hey, Hemant, go ahead.
So, uh, so part of my role involves capturing evidence to maintain our PCI compliance for data, and I can recall some of the requirement is to make sure the minimal footprint of data in store and transmit. So, my question is, when you're using these agents, how much footprint they're gonna leave? How do I trace back? Because now when I'm thinking about filling up the rack matrix, so far it's been person who's accountable or one who is responsible. So am I looking at putting the names of agents now? So I'm just thinking about this, thinking out loud.
So if I'm not wrong, then the question is, if I have an agent in deployment, uh, how do I ensure that what is the data footprint of that agent has either retrieved, stored in memory, or have generated throughout? Am I correct with that understanding?
Yes.
Yeah. So the answer is day 14, day 15, and day 16. I'm not going into depth because this is where, as in day 13, it starts deployment and observability, and then it goes till day 16 on governance, cost. So when we start covering the AI ops, observability, eval, and governance, 4 things together will help you trace every step, every data point that is either retrieved by agent during the context retrieval, or has stored in the memory, or has used that to generate some kind of an output. And that is why when I said where it is, what must be logged from day one, you not only log the prompts, you not only log the tool schema, but you log goal, plan version, prompt version, tool schema version, input, output, retrieved source IDs, rejected evidences, model response, user approvals, error, cost, latency, and stop reasons. Why did your agent stop at that particular step? Even to that, as in there are few other things that are have not written here, but everything is logged from day one, so that when you come back for dispute or for compliance, you know from the observability layer what is actually part of what constitutes the agent context, the retrievals, the memory, and everything else. But for now, the shortest answer I can give you is wait till day 13, 14, 15, and 16, and you will know how to do it.
Okay. And the other question is a lot of the terminology that you're using is I'm not much aware. So you have a document like a liner or two just the day before I come in, if I can just go through and get some understanding of what you're talking
Yes.
about for the day, that would help.
Could you give me an example of some of the terminology so accordingly I can think of?
You're talking about vector based, you're talking about
Fantastic.
how tokens can
Fantastic.
impact. So just a little understanding of what you'll be speaking. If I know ahead, maybe that will help me connect the dots.
Yes, definitely. Part of what you asked, token and other things, is covered here already, which is okay. But nonetheless, the point taken, I'll share a vocabulary with on the roadmap before the
Okay,
session.
thank you.
I think Arup also had the same session, same request. Yeah, correct. I saw one question. I'm worried about the technical depth as I do not have IT background. Uh, that is, as in, I won't say that is perfectly all right, but from my personal experience, uh, that is not a blocker for you at any point of time, because what we are discussing here is from scratch how does certain things happen. So we go to agent and we'll try and deconstruct the agent architecture in goal, observation, state, act, decide, and environment kind of a terminology, right? So no worries on that part. Even the same LLM, three different controllers, what is a workflow, what is a copilot, and what is an agent. So definitely we will have everything that you are asking in the session. The only thing is that do not get bogged down by the word agentic AI. If you start applying your standard practices that you perform in your day-to-day workplace, I think you should be able to catch up on different aspects of the architecture point. What might be required additional is that nuanced understanding why I'm looking at rate limit, or why I'm looking at multi LLM provider setup from the beginning. Why can't I add later in the stage? Something like that could happen, but which is okay. With the time, you will come over that. And do we need to install Agents SDK also with the desktop? No, we do. We do not need to install beforehand. We will know. We will actually practice how do I install different libraries required for my application within this setup, right? So don't worry about that. Uh, any other questions before I go into the what is an agent and what is an LLM setup? If there are no further questions, then I would like to start
Just
with.
in case we have some travel, I have one weekend travel plan. Uh, I can catch up on the recording, right? On the roadmap.
Yes,
Okay.
yes, yes. Okay. Okay, I'll close all my links so that you have only two setups. So now that we have discussed curriculum into the phases and what Cloud Code certification requires as part of its assessment, let's now move and try and deconstruct the word that we have been hearing a lot throughout, right? So we have heard about this agentic AI, multi-agent orchestration, and all other things, even the large language models and everything. So before I jump into uh, any discussion from my side, would love to hear your thoughts on what is an agent, uh, where have you seen an agentic workflow coming into picture? Have you seen, have you used which tools, which agents you have used in your day-to-day life? If couple of you could share your uh, experiences or uh, your own thoughts on what is an agent would be really helpful. Srividya, go ahead.
Yeah. So what I understand is agent has a set of tools, memories, etc., as per the definition. But in general, right, if you look at an application, there are different things to do, if I may call quote unquote things to do, maybe independent or dependent on each other. When I reimagine, for example, I was running the architecture governance side. So
Mhm.
on that, I had designed and built an AI assistant wherein I could have 3, 4 different functionalities. One is, of course, a Q&A. Second
Mhm.
one is a design review agent. Another one is a architecture pattern recommender and generator. And maybe the fourth one is where is the how far your responsible AI approval has gone. Look at your status and all of that workflow. So in a workflow, I may have some deterministic elements and some probabilistic elements. So I will have to either stitch them in a workflow or run them independently, depending upon what I'm reimagining, right? So every unit of this thing which is going to solve a particular problem, for example a design review agent, right, does a particular thing, and it may be dependent on the previous calls, right? So it'll have to figure out which one to call next. That is my understanding of that. Of course, coding agents are different things, but yeah.
Okay. Okay. Anyone else? I have a question from Mumtaz. Mumtaz, I'll come to this question in a minute, but let's first understand what is the opinion of members on what is an agent.
So,
Go-
okay, anybody else? Otherwise, I'll go.
No, no, please go ahead.
So, an agent can perform, I would say, two kind of or two situations can be deployed for an agent to perform certain tasks on your behalf, or you can program it to perform such tasks. One is where an agent just performs a task which is step by step properly documented, and you can have the agent do it, but it might be wasteful because that might become more like an automation and not an agent. I think a lot of people are doing this, and my recommendation to at least to my teams is that instead of an agent you look for automation, right? So there are a lot of use cases where automation is being done by agents. The real value of the agent comes when there is some level of context based understanding, assimilation of context based understanding, and based on that, either there is a recommendation or a decision taken. If you are allowing it to make a decision, then the question comes: is it going to be human in the loop, on the loop, or you just review what happened? But then you should have the ability to, kind of the agentic architecture should be such that you should be able to restore to what happened before the agent made the decision. So depending upon what systems you are running, you may want to be very careful. So these are the two areas where I would say I can use this as an example to define what an agent does.
Okay, fantastic.
Oh,
So, okay,
yeah,
yes, Vijay, go ahead.
yeah. Agent, what I am thinking is it does like it takes an action and does iteratively until the job is done.
Okay, so let me open an Excel. A couple of interesting points have come up, and I'm going to start with what Vijay said just now. So, Vijay said two things. One is goal, other one is action. Okay, fair enough. Any other thoughts on this? Sorry, my screen might not be visible. Let me just zoom in. So, we'll go there.
So does the task comes in the action?
And that's okay. Task may not come into the action.
So if I may take 30 seconds and,
No issues. Go ahead.
share with the team the background or a little bit of basics. So I think when I heard the one of the podcast, what it said is that if I want to search for an flight to London, it is a task. This can be done by any Google search, etc. also. But if I want to plan my London holiday, then agent or a agentic agent capability is I say that I want to go to London in the June and I want to cover this place and my stay there will be 7 days. So please plan a holiday for me and also book the tickets and the hotels. I would like a three-star hotel with the vegetable food available. So more the specific prompt and more the specific things you give it to the agent, and the agent should have capability and the actions allowed, permission allowed to go for an agent to go and perform the action on behalf of you. So you need to kind of give the agent those permissions to do action on our behalf. So planning the entire trip of your London, including the flight booking, hotel bookings, and the itinerary, is agent AI. But if you just ask this, give me a itinerary of the 7 day London plan, then it's just a generative AI. That is what I had taken from that podcast.
Okay, fantastic. Some new keywords. I'm taking few keywords from uh, Pankaj discussion also. He said two things. One, agents can perform documented step-by-step tasks, and therefore a topic came that agent versus automation. Now, let's deconstruct what an agent really is. So an agent owns an outcome across a loop, and always remember that agent is a control system. We will not look at agent as an something like I ask a query and I get a response. Is not just an this simple loop is not an agent. Agent has multiple aspects that needs to be fulfilled in order to become an agent, and those aspects are every agent needs to have a target or a goal. It needs to therefore have an understanding of what is the target, what is the success looks like, and when do you stop. If this is missing, then the system will optimize for a wrong task. So an agent will have properties which is a goal. So agent will have a goal. Now let's take an example which I think Vijay or Bhavesh just now gave. So the goal is to say that, okay, user wants to travel to London, and agent needs to build the end-to-end sorry. Okay. Now, this goal will lead to different aspects of the agent. So it tells you the target, it tells you the success. When the agent is successful, when agent has the final itinerary to be done. The stop rule. When do you stop? Because if any of these three is missing, system will optimize the wrong task to be performed. Then an agent can observe in the real world from text, from web, from files, from databases, or from previous conversations and memories. So an agent runs towards a goal by observing the surrounding. That means the text input, the files, the web, the databases, the previous memory, understands where it is currently, right? What step the agent is right now at. Once it has these three things, it decides what to do next and then acts using the environment. Either acts using the APIs, acts through repositories, acts through browser, or brings in human for more questions and answers, and then generates the feedback either for itself or for the end user. So what was the result of this entire one step? Then what is the error? What is the cost? What is the new state that I need to work upon? And it repeats until the stop rule is fired. That means there are two things that are going to happen. One, agent work towards a goal. Number two, it will repeat until the stop rule is fired. Now, stop rule could be your token budget. What else could be a stop rule? One stop rule could be how many tokens an agent can consume. Can you quickly think of other stop rule when agent should stop?
If the code
Going
is a
beyond the budget.
Going beyond the budget of both token, the cost, and retries. Correct? How many times an agent can run in the loop? That also is a stop limit or stop rule. And any error that has appeared in the single step becomes the feedback for the next observation on the go. So that is an agent. So agent, if you in simple words try and deconstruct the agent, agent owns the goal, plans towards the goal, chooses the way to act, retrieves the history or memory, acts using tools, and then observes the current step or current state always, which becomes a feedback. So an agent will always have a goal, needs to plan towards the goal. It will choose how do I act to achieve the plan, which will help me achieve the goal, retrieve the memory from the past conversations or the databases or somewhere else, act using the tools. Now, web search, LLM might not be able to find something. So it can go on web and search around it, come back with the responses, observe, and then give you the final answer. Now, there is one additional thing that always comes into picture: responsibility and few other things. We will see agent taxonomy when we go to Anthropic Safety Framework, but first we need to deconstruct this agent loop. Now, before I go any further, is this 7 steps that agent takes in order to arrive at a the final outcome? Are these 7 steps clear? Now, some of you might ask a question that, okay, what happens when agent is going to go out of scope, or you do not agree with what agent outcome is? So in that case, the feedback is the step which will help agent understand either you have disagreed or it has gone out of the scope. And that is why your goal, the target, the success rule, and the stop rule makes more important artifact rather than just a theoretical title when you're building whether a single agent or a multi-agent system. I'm going to wait here for a minute. Yeah, I think Arup has already asked the same question. So
can you just state few lines about the third step, which is the state?
Okay. So what the controller believes now, if so, the goal is your target state. There is a success rule. What does a success rule looks like? And the stop rule. The stop rule is agent can retry 15 number of times. Okay. Now, if that is the case, you and let's say through observation, you came to know that I am on my 14th attempt. That attempt is 14th number attempt is what your state will tell the agent that, okay, your retry number 14 is going on. You only have one retry left. Because the moment you complete 15 retries, your retry budget is over. You are going to stop. Same is the case with memory. Same is the case with model judgment. Same is the case with which tools are available. So in the state, the agent will know which tools are available for me at my disposal to work along with. So any information which can be observed directly and which helps agent understand the current status of its task, how closer, how further it is from the goal, that is a state.
Yeah, does the agent allow to see the difference of each try?
Yes, that's what you do through feedback. You do not just record the feedback, but you also record it with some typed hints that this is retry one feedback, retry two feedback, or memory user specific or tenant specific or whatever you have. So feedback always
I have
gives
a
you
question.
result, which is just 1 second only. So
Sorry.
result, error, cost, and the new state will be given by the feedback. And that's where the state comes into picture. Yes, Vijay, question.
Yeah, sorry. Is the agent considered as a software for talking to the LLM? Or how do we define an agent? Like, can you please tell me?
Okay, so agent is defined in this way only that, okay, let's go to the drawing board, which is what I was coming to. And can I answer your question in 30 seconds? Because that's where I'm going to actually.
Yeah, sure. No problem.
Okay, fair enough. Stop rule, guardrails, are they both referring to the same? No, guardrails is superset. Stop rule is when your agent should stop. Guardrail is protecting your personally identified information, your compliance, some of the things that you want agent to use, agent not to use, your sandbox policy, all those things will come under guardrail. Okay, so now therefore, agent owns an outcome across a loop through these 7 different steps. Now, therefore, the question comes which Vijay has asked, what is an agent? So the agent is different than a workflow, a copilot, and agent. So workflow, who sets the next step? The developer sets the next step before the runtime. When to use, the process is stable, regulated, or high risk. A copilot, a human operator sets the next step. The task that needs human accountability is where you will use the copilot. And an agent decides the next steps through the policy and the model. When to use it, when the state changes, tools exist, and path is not fixed. So in simple words, agent, in a way, does all these 7 things. But agent, how do I define the agent? So agent has a reasoning capability which is offered to it via large language models. It can act using tools, and therefore it can remember the task it is doing. Does it answer your question, Vijay? Can we ask the agent? Okay.
Yes. Yeah.
Okay. I'm going to pause here for 30 seconds. Any questions that you have on this particular loop? Agent owns an outcome across a loop and the same LLM 3 controllers.
Are the types in agents?
Types, no, these are the 3 different systems that you can build with LLM. Types of agent we will see sometime when we go to the agentic setups.
Okay.
As in, you have single agent, multi-agent system, React agent. These are some of the policies: React, PDM, PPDM. Agent with memory, agent with no memory. We'll go there and we'll discuss it. But I want to give a very clear indication of what is an agent.
Okay.
An agent, in simplest word, is an autonomous system powered by a large language model that can perceive its environment and reason through complex tasks and use tools to take action in pursuit of a specific goal. So in pursuit of a specific goal, agents will perceive the environment, maintain its state by observing the environment, reason through complex tasks via the policy plus model judgment and some actions through tools, and work around that. That is the simplest definition that you can define for an agent. So an agent, in the simplest words, is this. If I have to put it across the English, then this is the definition that you can think of. That an agent is an autonomous system powered by large language models that can perceive its environment, reason through complex tasks, and use tools to take actions in pursuit of specific goals. I'm going to pause here because formally putting a definition.
So Shivranjan, are you saying a single agent is autonomous? A single agent system has to be autonomous?
They can be an autonomous. How much autonomy you are providing is based on your entire framework of 7 steps. Goal, observe, state, act, decide, environment, feedback.
Okay, this is where I think there's a thin line between the automation. Say, for example, I have an N8N automation, and in between, I have to use LLM for certain kind of text generation, and then pass that JSON output to a next workflow, right? There also, I do have a small agent, right? But I've integrated in a workflow. Right? That's where I'm a little confused, right? Where do you use the word autonomous, and where do you use it?
Okay,
Controlled
so
environment, yeah.
agentic workflow is different than a traditional workflow. This is your robotics process automation workflow. The developer decides the next step, right? The step is decided before even the deployment happens. This is how 1, 2, 3, 4 will be performed. Now, when an agentic workflow is running, even the next step is decided by an agent, and to perform that step, another agent is working. So autonomy is more about how much agent can access, how the tools are made available, how the tools are chosen, and think of the autonomy or autonomy towards a stage where can your agent disburse the loan amount or can it just tell you by looking at different aspects whether this person is eligible for a loan or not?
Got it. Okay.
Right? So if your agent is going to stop at a point that, okay, this person is eligible for this X amount of loan, these are the 5 documents that this person has submitted, these are the running documents, this is what it is. Human decides whether to disperse the loan or not. That's a lower autonomy. The moment agent takes that decision that, okay, disbursement also has to happen, and performs the disbursement by looking at the account number and authentication and other things, that becomes a fully autonomous system. Now, within that, you might have a workflow that, okay,
Yes.
agent step 1, parse the documents. Is this candidate, is this person has submitted all the documents or not? So therefore, there is a workflow which checks all the documents are there or not. Aadhaar card, PAN card, other document, salary, employee number, employee is in the office, the professional ID has been verified or not, all those things. So that workflow can run separately as part of your one agent. But then that agent's output will be reported to your another agent to take it forward.
Okay, understood. So it's not that they are two different things. You can actually combine both to attain whatever application you are building.
Yes. Suresh, I have a question and I'll take it here. N10 Zapier are workflow automation AI systems, or are they agentic AI systems? So any agentic AI system will have a runtime state, policy, and model judgment. And we will come across what do you mean by a runtime state, what is the policy, and what is the model judgment. But if your agent does not have this, if your agent does not work towards a goal, or if your entire setup is not working towards a goal, is not deciding basis the policy, does not observe from the environment, or does not access the setup or the information via tools, probably it is a workflow or it is an automation setup. To be a truly agentic system, you need to do this. So an AI agent is an autonomous system powered by large language models that can perceive its environment, reason through complex tasks, and use tools to take actions in pursuit of specific goals. Now, to deconstruct this, one simple line, let's say there are two things. One, you have a goal. Okay, I'll write here goal A and goal B. Sorry, goal B. A goal A is, let's say, here your agent has everything. Agent can choose the tools. There are fixed set of tools integrated within the setup. So what we are talking here in terms of both of these agents is that we are looking at their different autonomy level. When we start building an agent, we will talk about agent autonomy. That is where we will try and cover this, that how does this differs and why one is an agent and also other is also an agent, right? So fully autonomous, fully autonomy or partial autonomy is what we need to look at when we are looking at agents. Right? And Arup's question, so an agent makes decisions, hopefully the workflow is logged for auditing later. Yes, that's the work that we do in the evaluation and observability and deployment. But is the goal A and goal B difference clear, that if your agent can choose the tools and therefore act based on that, you are giving it an full autonomy, that you choose your tools. We do not define which tools to be used for which task. Goal B, which tools to be used for which task is fixed. When to use them, that is choice of an agent. So that's the difference that you can start looking at. And it will be made clear, or it will become more clear to you once you write your first, once you observe your first agent maybe tomorrow's session itself, you will build your first agent using Claude Code, as in the Claude app that we have, right? So that is where the difference comes into picture. Okay, now one important aspect: an LLM does not make a system an agent. A closed loop with choice under constraints does. That means this loop, goal, observe, state, decide, act, environment, feedback, is what this loop makes an agent. If you take a simple LLM, that is not an agentic system. So is there a goal with a stop rule? Yes. Does the feedback change next action? Yes. Can the system change state outside of the chat? Yes. Can the system stop, retry, or escalate? Yes.
Yes.
Is when the agent is or full, all four locks are hold, feedback can change the next action, and that is why it is an agent. So your agent, if you were to redefine now, your agent will have a goal with a stop rule. Agent works with a feedback. That means the feedback of the previous step changes the action in the next step. System can change the state outside of the chat, right? You can retrieve, it can ask questions and fetch the information and change the state and then move ahead. And ultimately, can system stop, retry, or escalate by looking at the feedback? If all four are yes, only then it is an agent. If you keep anything no, it is not an agent, right? The agent is when all four locks are there, all four questions are answered as yes, they become the agent. Now, before we go to the other step, I want to answer this question. So an LLM does not make system an agent, because you might try and look at LLM as an agent. Always remember, agent has LLM for reasoning capability. LLM is not an agent. Agent gets its reasoning capability using the LLM. LLM is not an agent. Always remember that. This loop, or at the least these four questions, make this an agent. Is that point clear to everyone before I go to any other description?
Just for me, can you just one more time elaborate the point number 3? Can the system change state outside the chat with an
Yes.
help of an example?
Yes. So can system change the state outside the chat? Now, let's say you have a chatbot. You are asking it a question, and it is supposed to answer the question to what you have asked. Now, how do I convey? Okay. Okay. So I'm going to ask here one thing. Okay. Okay, not on Claude. I'll try and give you the other setup. So, what happens inside a chat? Can you tell me what happens inside a chat? Let's just try and break this down. So, uh, can you tell me what are the 2-3 steps that happens inside the chat? Let's say the chat is a healthcare provider. Let's say you are at a hospital and you want to take a medical care. Now you are using a hospital chatbot.
Mhm.
Now what things are happening?
I may say that I may give a prompt that I need to take an appointment of specialist in the particular area. Let's say kind of orthopedic
Okay.
doctor.
Okay. So you said that uh, I need a ortho appointment.
Mm.
Correct?
Yeah.
Right? Uh, Now, uh, ideally, what should happen? It should fetch your patient ID, correct?
Mhm. Yeah.
Fetch patient ID. Then it should
What's the
fetch
first?
your history
Yeah.
and identify correct ortho specialist in your team,
Yeah.
as in the hospital's team, and then it should book you an appointment.
Yeah.
Now that means here two, three things are going to happen. One, make the payment,
Yeah.
uh, provide you the token number. Now,
Mhm.
if make the payment, there has to be a payment gateway,
Yeah.
right, which handles the payment status. So unless payment gateway says that payment is successful, token number will not be generated and you will not receive the token. Once the
Got it.
payment is successful, you receive the token.
Yes.
And this received token is also stored in your DB, let's say temporarily.
Mm-hmm.
And this is I'm adding additional, but because I need to check with the doctor. So now this token, you enter the doctor's room. Okay. So consultation happens.
Mm-hmm.
Doctor opens their portal.
Mm-hmm.
Uh, they write some prescription, right? And basis this prescription, your info is updated.
Correct.
Now imagine payment, token number generation and giving it to you, which is a real time setup, and your info is updated for your patient history. Three things that are happening which are beyond the chat,
Got it.
right? So this needs to happen. Your chatbot will give you which doctor is the orthopedic specialist. That's all, nothing else.
Okay. Rest
Your
all is happening outside the chat.
right. Your agent will come to you with your patient ID specific to you. Find out if you were working with same any other doctor inside the hospital specifically. Suggest accordingly, right?
Mm-hmm.
And then book you an appointment. We'll generate a link for you. You make a payment, check the payment gateway status. If successful, generate a token for you. You receive that token, you go to the consultation, doctor opens their portal, they write their prescription, that info is updated in your history. These things are happening outside your chat box, and that is what it makes an agent, because it is doing things on your behalf. And these steps are not fixed. So you are not selecting orthopedics department first. You are starting with your human query that I am feeling pain in my index finger. Agent decides that you need a orthopedic surgeon. You need to see a orthopedic surgeon, but uh, or let's say you say that I have a chest pain, then agent should ask you a follow-up question: what kind of a chest pain? Right? Again, I'm giving a very outside context example, but in case of a chest pain, and this is what healthcare helps me understand these concepts more in a nuanced way. A chest pain is not always a cardiac emergency, and chest pain is not to be ignored as not an cardiac emergency. It is both. So there has to be a appropriate follow-up which leads to a conclusion. Now, if that has to happen, agent needs to have the reasoning capability to reason through the steps and then book you the ECG, as well as the cardiac surgeon's appointment, as well as general physician's checkup at the same time in one go. That's
Understood.
the agentic capability,
Understood. Understood.
right? That's
Thanks for
the,
the example.
yeah, and
Yeah.
that's the system change state outside the chat. Arup, your question is in this case, who owns the agent? The one who has deployed it, the hospital. The hospital owns the system. Patient cannot own the system. Hospital has to own, and that is where the GRC comes into play, the governance, risk, and compliance. Okay, so we said a lot of things. I said two things about this, that agent gets the reasoning capability through LLM. So now let's understand what is an LLM. But before I jump to what is an LLM, question that you have that you want me to answer.
So I have a question.
Yes,
Uh,
Vijay.
how much freedom does the agent have? Is it all defined or it can go to any extent?
That is defined, that is policy.
Okay.
Yeah. Something happened. Also,
So the other question is the operational cost. Are we talking only of tokens or there's more to it? Memory or hard disk?
everything.
And
You store every interaction, so you need to have that also considered. You store every interaction, you own the infrastructure, your agent has to be up always, all those things. So the cost is not just a token. Token is important part of the cost, because that defines, let's say, your 40, 50, 60% of the cost, but rest of the things are on your infrastructure too.
okay.
Because if you are not going to go with Gemini, Claude, or OpenAI LLMs as an API, you are going to host your model on premise of the hospital. So for one of the project I was working with a ICMR, the entire data annotation pipeline and the entire inference pipeline, I had to host it on-prem. So in that case, the on-prem setup is my cost. And for critical applications, that might be a very, very huge at the start, but as the time goes on-prem cost is also much lower compared to the standard cost. But the bigger problem is you own everything in on-prem setup, everything, right from the inference to other things too. So that's why uh, you know that's why it is important for us to understand the cost of what happens. Hope that answers question.
Yes. Thank you.
Yeah. So now when we say agent gets its reasoning capability through LLM, we on the day one itself we need to deconstruct what is an LLM. Okay. So here is a statement: the cat sat on the, and I want you all to give your responses in the chat to complete this sentence. Quickly. Okay. Wow. Couch, mat, wall, floor, me, bed, floor. Fantastic. Okay. Nobody said, and I'm fortunate enough. Sofa. Fantastic. So let me take this statement. So most of you said mat, wall, sofa, me, as in the individual who owns the pet, mat, wall, anything else that I have taken?
Floor.
Floor, okay, interesting. And
Bed.
sorry,
Bed.
bed, okay, fair enough. As in that's what we needed. None of us said Mars, sun, philosophers, quantum 12, or I don't know what, Titan, whatever. So we did not choose these, but we chose these because we, as an observers of a real life events, have observed cat sitting on some of these real time objects, whether it is a mat, wall, sofa, me as the as someone who has the pet, the floor, bed, laptop, desktop, phone, whatever. That means the idea is that a language model should be able to do the same thing for me. If a human chooses the cat sat on the mat, wall, sofa, floor, bed, or something like that, a language model is expected to perform the same task for me using the compute. Am I correct with this expectation of a language model? Okay. Arup says yes. What about others?
It would be a human reasoning.
We will see that why it needs to do that way. But my question is that expectation appropriate? That language model should be able to do the same thing that I just did for myself. Yes, if it has observed the past. Fair enough. I think someone had
Yeah,
raised.
but then it is as good as, normally how people think. And if the LLM just incorporates the art of normal, an art of everything that people generally do, then it is dominantly working in a very constrained environment, not very, but yet constrained environment of assimilating anything and everything that humans have done till date and give you an answer based on that. Art of possible from the LLM will get very restricted.
Agreed, but at the principle, a language model needs to do something like this, that they have.
Yes, in that way, yes. Do it, but maybe do it very faster,
Yes,
with reasonable and more options than what somebody could think very quickly. So some of those things will,
correct.
yes. And LLM is supposed to do that, yes.
Correct. Now, coming to what you said uh, on the huge, I'll take that word large.
Yeah.
So, as a human, if I ask you a question, what did you eat yesterday? That's the biggest and difficult question that I might ask to anyone, because it's very difficult to recall that. Now, if you because that's not something we think of constantly. Now, if you look at these words also, these are very commonly observed words. Probably you are looking at mat, wall, sofa, floor, bed, something like that. And that's why the words are coming to you. Now, imagine a language model which can take a vast amount of data that is available at its disposal, identify the patterns, and come out with a statement which looks real, natural, yet it has gone through the principles of algorithms, compute, and the language modeling, natural language processing, and all the things. That is a large language model for us, in a simple word. Now, what it does, it is trained on large amount of data. Now, how much is a large? So to put you in the perspectives, the Mythos class model is a 10 trillion parameter model. Now, what is a parameter? It is a one parameter will hold some information about the model's knowledge and capability. Just assume that we'll go to the parameter, deconstruct it when we go to the vector databases. But 10 trillion parameters, by some empirical laws, each parameter needs 20x tokens. Now, what is a token? Token is a subword. Now, let me take one sentence. From here, I'll take this outcome. I'll go to tick token. Where is tick token? Oh, wait. Okay. OpenAI tokenizer. Okay. What happened? Okay. See this. So, how many words? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22 words. Now, if you see here, it has converted into 26 tokens. So each word is a separate token here. But how do I show you? 1 second. I will have something here. Okay, so see here. OpenAI was divided into 3 different tokens: Open, AI, and apostrophe S. So each word is therefore divided into smaller subwords, and token is not a character. Token is not a word always. Token is part of the word. Sometimes it could be a single character, sometimes it could be a entire word, or sometimes it could be a part of the word. Now, to give you, I'll just take some Hindi word. I'll take this. Okay, take this. So you can see this. In Devanagari, it has converted into they as one token, one as another token, A and G as one combined token, and Re as another token. So 4 tokens to represent the word Devanagari. Now, this is what the tokenization is. So LLMs will always work with tokens and not the words as a whole. Now, why this is important for us? The subword is a token. It is a part of the word. So by a quantity perspective, a Mythos class model, which is a 10 trillion parameter model, needs 20x tokens. So 200 trillion tokens are expected at the minimum. Now there could be more, like exponentially more than this, but this is the estimation that I'm trying to give you. A 200 trillion tokens roughly realize to 160 trillion words. Roughly 160 trillion words, and therefore that roughly 160 trillion words, if you take 4 bytes for each word to be stored in the memory, then probably you will have 640 trillion bytes of memory required to train a Mythos class model. Now, this might be significantly more than this, but I'm just putting this as a number in a perspective that this much of information is passed to the large language model in order to get trained on the data that it has access to. And that is why the large language model has seen these patterns and understood the linguistic nuances and other principles behind it, so that it can generate some new responses. Now, where does it leads us to? The model writes one token at a time, and then it writes the next token. So LLM, although tries and predicts, completes a sentence, writes an email for you, generate a code for you, in principle, it is just generating one token in the output in order to complete the statement or complete the task. So the cat sat on the mat and You can see the and has got highest probability, licked, it's, and it stopped because maybe paw or whiskers or something like that would come into the final picture, right? So a LLM's output generation is always a one word or one token generation at a time. That's the first part. Now, what happens in the LLM is the cat sat on the mat and licked its whiskers or whatever it has to, goes through a pipeline. The first stage is prompt and tokens, the query that you have taken that are already written, they become the input. The token and its position are fed to the LLM in the step 2. A token may see itself and earlier tokens, which is known as self-attention, then go to feed forward pass. Again, these are the terminologies from neural networks, so don't worry about it. And then score the vocabulary. So this score the vocabulary is basically coming from here. Wait 1 second. This mat. Mat is 72%. This is where the score the vocabulary part comes into play. Let me just zoom out a bit. So mat has got 72%, rug has got 14%, floor has got 9%, sofa has got 5%. Scoring the vocabulary, we'll look at the scores of each word in the final layer. Now, from where this is, sorry, can you, thank you. Now, the idea is every LLM works with a vocabulary, and each token in the vocabulary gets some specific value, as you see here, like a mat, or next time it is and, dot, then, and comma. Lived, slept, ate, ran. These are the words from the vocabulary of the LLM that I'm presenting to you. So every LLM will have its own vocabulary. After the feed forward step, there will be some mathematical scores provided for each token in the vocabulary, and one token will be chosen at the end. That becomes your generated output. So if you see an LLM, let's say I'm going to use Claude here, and I'm going to say, what is the meaning of life? It is not generating this as a passage, but it is generating as one token at a time. So first there would have been generated, then apostrophe is, then no, then single, then settled, then answer, like that. And then it would have completed the whole paragraph. That's the whole idea, right? Now, underlying the large language models, there exists an architecture called transformers architecture, and it solved 3 different problems from the previous generation models, which you can read about, recurring neural networks and LSTMs like that. One, sequential processing. So the RNNs and LSTMs were doing batch processing and sequential processing. That means if there is a statement, the robbers robbed a bank located at the bank of a river, they would process one word at a time. So to process 12 words, RNN and LSTM must finish first 11 words. In case of a transformer, if you look at, they do process all words, entire input once. So the idea of where does this bank comes into play with respect to robbers is not known to RNN beforehand, but it is known to transformers in the first go itself, always. Now, slightly difficult to.
So you said RNN.
Huh. Go ahead.
RNN is one unit in order. Okay.
Yes. And transformers entire input at once. So parallel input processing happened in the transformers. Apart from all the technological marvels that transformer offered, this was one of it. This was the most critical. The second one is more critical for me, and if you could observe this change, we as an humans are at a task to define the robbers robbed a bank located at the bank of a river. We are supposed to locate and assign the meaning of word bank twice in the same sentence. Now, if that is the case, then in the previous generation models, what used to happen was at the first, the word the will appear, right? Now, if the word the is appearing, it is going to take entire space of the context. The second word comes into play, the robbers, and they split the context. By the time you are going towards the word bank, the has lost its importance in the context. By the time you reach the second bank, the robbers have lost their context or their meaning in the entire context, and now you only see river, the bank of a river. So the chances are higher that bank will be processed as the river and not as the financial entity, which is why the transformers fundamentally changed this. They introduced something called as a self-attention, which could look at the entire sentence at once. The robbers robbed a bank located at the bank of a river, and the self-attention helped transformer overcome the problems that we were seeing in the previous generation. And then which tokens can the model see? Same sentence. So if you pre-fill, why the first bank not use river while the model writes a sentence left to right is the problem. So if you click on the setup, they may use only one token itself and the past. Gray tokens are for the future. So anything, now if I try and decode, already written, they are not written yet. So a token may see itself and the past, it may not see the future is the problem. In decode, it cannot see a token that is not written yet. So that means these LLMs are now working at a stage where they can identify which tokens to be seen, which tokens not to be seen. Now, this brings to an important distinction between all the three different types of systems you would have known previously. The generative AI or large language model based systems, the model size is really large. The training data volume is very high. The labeling of the task is very low. There is something called as output determinism is very low unless temperature is set to 0. The state is a prompt only unless you add a memory. Actions on the world text unless the tools exist. Failure mode is very high. Human role is author of the loop, and latency is high per token, higher per loop. Explainability is very low. Full internals are never available because everything is going through the transformer architecture, which is a self-attention per se. Okay. So I'm going to wait here for 30 seconds, and then I'm going to go to the agent loop or the agent aspects. But before that, if you have any questions on what is an LLM, you need to remember three things about an LLM. LLM, in simple plain words, is a generative AI system or algorithm or whatever you want to call, which has been using transformers as its core. Okay, there are different other algorithms. There is diffusion, there is variational autoencoders, there is something called as generative adversarial networks, but we will stick to transformers. It processes parallel input. And the third thing, the most important, is there is a self-attention. And we will see self-attention in when we go to knowledgeable agent on day 5, when we are building the first track, we will see how the self-attention works. If these three things are there, uh, this is what LLM is. And there is one thing that you always need to keep in mind, that output is always one token at a time. Simple. Okay. Now I'm going to pause here for 30 seconds. I'm going to wait for you to give me your questions. Otherwise, I'll move to the agent loops, the types of loops that agent has. Yes, Bhavish.
Shivarajan, I have two. One is a confirmation that
Yes.
current Claude or Gemini or something is using a transformer this thing pattern and not the sequential pattern is the confirmation I need. And
Okay.
the second one is how the token consumption happens is you showed us that when you put the input, how it counts. But
Yes.
does the processing which happens behind also consumes the token and the output also consumes the token? Or is it something we are gonna see in the later days? Then I'll hold my question.
Yeah. So to your second question, we are going to see it in the later days. How does token economy happens? So that's not an issue. Your first question, I cannot confirm that, at least in terms of Gemini. Claude, to a certain extent, yes, it works on transformer, but there are certain models of Gemini which works on diffusion also. So there is Gemini diffusion 2 in the market. Not
So diffusion, I think you said we will see in the later days.
No,
But what
diffusion
you
will not cover, because diffusion
okay,
is one new architecture that has come into play.
okay.
So in a biggest thing of diffusion is, here you saw one token getting generated at a time, correct? In the diffusion, let me see. I have diffusion set up here? Okay, I'll say conception or Mercury. Okay. Okay. See here. I don't know if you were able to see it or not, but I'll suggest 10 LLM prompts for DLLM. Okay. Right, so it generates a block and then it tries to reduce the noise from the block, and that's how it does. So diffusion is a whole new and different kind of an algorithm. Okay. Hope that answers your question, Bhavesh.
Yeah, but the RNN is not in the picture now. It is dated.
RNN is not in the picture in terms of LLM.
Yeah.
Certain applications will still follow RNN and LSTM, but that's very specific applications,
Okay. Okay.
right?
Got it. Got it.
Okay. Okay.
And
Hmm.
Shivarajan,
Hmm.
when we are making these prompts to the agent, are there intermediate replicas or a cache that's helping us to respond faster with repetitive questions from multiple users?
You can, but that's what we will do when we go to, wait, somewhere here, when we go to deployment, when we go to secure agent, that's where we will see those things.
Okay.
Okay. Questions. It's 4 minutes into the left into the session. I don't want to overboard, so I'll hold a taxonomy and the agent patterns for tomorrow. We'll cover these 2 points and we will cover the anthropic safety framework. So I'll just show you anthropic safety framework. This particular, so this is responsible scaling policy. this is the thing that you will see on your roadmap also by today. You can go through it before tomorrow's session, and we will discuss on this. This along with these two, taxonomy and the agentic patterns.
So Shiv, one question. This
Yes.
page that you are showing up currently, is this available to us also? No?
This one, introduction to agentic AI,
Hmm.
it will be made available to you by today. As in,
Okay.
whenever Pinjala uploads the recording,
Okay.
uh, they will upload this file too.
Okay. No. So that I understood. That's the recording. I'm
Yeah.
saying that seems like you're accessing a web page for this. I was
Yeah.
asking if.
This also will be available to you.
Yes.
Okay.
Yes.
Everything that we are using in the session, every
Yes.
single thing will be available.
Okay.
Yes.
So you were showing that Anthropic page that is called as what? So that I already referred, Anthropic Safety Framework.
Uh,
And so safety framework and scaling policy, these are two different things, huh?
yes. So there is 1 second. I'll show you there both the things. So we have two things. There is it comes from their frontier safety roadmap, and then there is a responsible scaling policy. Also, they have their own guardrail. So there are 2-3 documents that we need to look through. So if you use their Fable 5 model, you are not allowed to ask certain questions. So the constitutional AI safety levels, and what their empirical research is. So all those things needs to be discussed in detail. So Claude's constitution is there. Our vision for Claude's character. So that needs to be go through. So we'll share these also along with what you have, right? AI safety level 3 protections also you can activate within Claude Code or whatever you are using. So those we need to see one by one, build a rationale around it, and therefore build the first agent as an architecture. That how do I ensure that these components are there, which these parts of prompt suggestions by Anthropic are there in my prompt or not. So those things we will need to discuss. Like you have a jailbreak. So there is a very classic use case that I will tell you. There is a difference between jailbreak and a prompt injection. We need to define that much earlier as a solutions architect, that what is a jailbreak for my application and what is a prompt injection for my application. And for that, tomorrow we will see this OWASP top 10 for LLM applications is what we will refer to. So I'll share this. Here. Okay, so this is what you have. These are the 10 different things that you can look at. These are the 10 risks that are generally shown by OWASP. They keep track of top risks in the LLM and agentic AI setups. Previously, they used to keep track of other things too. Now they also have added this. So you have prompt injection, sensitivity, excessive supply chain, data model poisoning, unbounded consumption, misinformation, hidden context. All these things are what we need to see through the safety framework, and then arrive at a kind of a mental model to say that, okay, if my agent is going to work on this way, then I'm going to build these two things for me. And my application should have these three things: this control from risk and compliance and other things. Hope that answers your question, Pankaj, because it's not just one document, it's a culmination of at least 4 different artifacts that needs to be put through a mental model to arrive at a selection of safety controls that I can put in my application as a solutions architect.
Yeah. I asked that because uh, when the needle is moving and it's already moving towards citizen development, people like us working in enterprise have to enable that, right? So technology becomes a lot more enabler as we move along, and therefore setting up all these guardrails at an enterprise level becomes a lot more important than just spinning up the agent. In fact, spinning up an agent and defining what the agent should do should be the job of the business, not technology. I should
Right.
be able to give them a secure, safe framework that safeguards them, their information, enterprise information, so on and so forth. And that's why I think, I got interested to understand,
Yeah, yeah.
how does all this culminate. So basically, if I have to write a harness for an agent, I can
Right.
write a lot of this at an enterprise level and offer that harness and the base agent to everybody in the enterprise, and then let them build a capability on top.
Right. Correct. That's the idea. And why
Yeah.
I said not one Anthropic document, because Anthropic safety framework might be applicable only to Claude, but OWASP is for all.
Yeah, yeah,
It's not just for one. So
yeah,
yeah.
yeah. Yeah, OS has been the guiding principle for decades, so I think they do have the know-how and the intricacies understanding.
Okay. Definitely.
Okay.
Okay. Uh,
And
yes, Hemant. Yes.
Shivraj, you were showing about diffusion, how the change is already happening, the way the token is processed.
Yeah. I'll try and
Um,
see diffusion versus transformers. Do I have?
so I would like to know maybe more about maybe points that can support that the cloud is will be staying around for some time. I feel more inspired to learn and continue and go deep.
Uh, See, it's not this or that. I think part of uh, part of your uh, pipeline will be diffusion based, or you know, uh, part of your pipeline could be a transformer based. We can't say for sure that Claude will stay on transformers for lifelong. They will use, because so long as there is a video and image processing involved, people have already started integrating diffusion as an technology. Uh, right? And if you see here, a modern generative AI often combines them. So a diffusion transformer use transformer blocks instead of traditional unit. Now, what is unit and what is convolutional neural network, we'll discuss separately. But a diffusion transformer has a transformer block on which the diffusion has been implemented. So we are at a crossroads right now. The layer is now thin between which model uses what. Gemini, I know because Gemini appointed someone as a head of diffusion team. So that as a fact, I know that Gemini is working on diffusion models for latency and for other of their tasks.
Okay.
Yeah.
So
But
that's
for
the
Claude,
reason. So that's the reason the Claude does not create images and videos, right?
no,
As of now,
Claude do create images. Is it? I'm not sure. I haven't used.
at least
Uh,
video it does not create, I
Video
guess.
it does not. Video it does not. Definitely it does not create a video, at least as of today.
So that could be one of the reason, right? That
Yes.
they are either not using or very using very less of a diffusion.
Yeah.
Diffusion.
Yes. Yes.
Okay. Thanks.
Questions?
Thanks you. I think the pace with which you're going is very soothing and able to grasp to some extent. Appreciate that.
Thank you. My request, I'll I know we are at 7 minutes past the our time. I'll just pause here. There is only one thing, that there is a paper called chain of thought original paper. I'll share this tomorrow, so that when you come back next week, you have already gone through this. This just spend some time on what is happening on the standard prompting versus chain of thought prompting. So when we start building our agent for the first time, you will know for sure that why we are doing something that we are doing on that day. So we'll share this as a specific paper and then this paper and these examples should solve most of your doubts that you have at the back of your mind. But anyways, we will discuss the prompt engineering component, but this is one of the crucial concepts that we will study, and the paper will be shared in the roadmap, definitely.
Okay, thank you. I think we'll depart. I have
Yes.
to take leave. Thank you very much. Bye bye.
Thanks, everyone.
Thanks, everyone.
Bye. Have a
Bye.
lovely
Bye.
weekend.
Bye.
See you tomorrow.